Hi everyone, this week in Level F we are going to be going over lessons 117 through 120. You will need worksheets 98 through 101, warm-up practice sheets 13 and 14, the appendix pages 4 and 5, colored tiles, a small container such as a cup, 2 dice, the calculator, the 4-in-1 ruler, the math card games, the percents and fraction cards, and the basic number cards. Lesson 117 does have corrections, so if your book was printed before October 6th, 2020, please follow the link in the description to find those corrections. In this lesson, we're going to learn the difference between independent and dependent combinations and solve some combination problems as well. The oral warm-up questions review solving combinations. So you're going to need to use 1 red, 1 blue, and 1 green tile for this first activity and have your student lay those out in a row side by side. Then, using the same colors, but of course different tiles, set out other combinations until all the possible combinations are set out. So for example, if the first combination was red, blue, green, the next one might be blue, green, red. Now let's look at how you can figure out all those possibilities without using the tiles.
So let's just draw 3 empty tiles or 3 positions, right? And you can just ask yourself, this is position number 1. What are my choices for position number 1? I could use red or blue or green. So I have 3 choices. For this one, once I choose one for this one, now I only have 2 choices for the second position, right? So if I chose red here, I can't put red here. And then for the third position, I'm only left with 1 choice. So the equation actually turns out to be 3 times 2 times 1 equals 6 possibilities. So now let's say that we have those 3 positions again, but we have 3 red, 3 blue, and 3 green tiles. So I could put red, 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 or blue, 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 or green, 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 right? So how many choices do I have for this first position? I have 3. How many choices do I have for the next position? I have 3. And for the third position, I also have 3. So my answer will be 3 times 3 times 3, which is 27. This equation or this scenario up here is called a dependent combination, and this scenario is independent. So they're both combination problems. This one is dependent, this one is independent.
After going through these examples, have your child solve the first problem on the worksheet and then ask him or her to explain the solution and state whether the combination is dependent or independent. Once the worksheet is complete, ask the in-conclusion questions, and then there is no scheduled game for this lesson. In lesson 118, we will be working with probability. Ask the oral warm-up questions, and if your child isn't sure about the answers, remind him or her about the positions. That's the information that you and I just went over. If the first position is taken by one game, that game cannot be in any of the other positions. Okay, so let's take a look at those first questions, the example questions for this lesson.
Okay, so here we have a probability scale, and the 0 on the left represents not likely to happen, and the 1 on the right is absolutely certain. So the first example says to express a probability between 0 and 1, either fractions, decimals, or percents are used. The next question says, what is the probability that it will snow at the equator? And they say that the answer is 0. The issue with this is that it actually does snow at the equator at higher elevations. So you could either modify this question to say, what's the likelihood of it snowing at the equator at sea level? Then the answer would be 0. Or pick somewhere else. Maybe what's the likelihood of it snowing on the sun? So the next scenario is, what is the probability that if you pick up one of your 2 shoes without looking, that it will be the left shoe? Well, you have a 50-50 chance, right? So this is where it would be. So you could represent that as 1/2 or 0.5 or 50%. All right, so for the next scenario, your child has 4 tiles, 2 green, 1 blue, and 1 yellow. And you put them into a container and you say, if I were to draw one of these tiles, what color is more probable? Well, the green is, right? Because there's 2 of them, so you have a higher chance. Does that mean I'll always get green? No. What is the probability that the tile will be green? Well, since the green tiles represent half of all the tiles we have a 50% chance of pulling a green, right? What is the probability that the tile will be blue? Well, that's 1 out of 4 tiles, so I have a 25% chance. And the same with yellow. There's only 1 out of the 4 tiles that are yellow. So my higher percent chance is pulling a green.
Next, your child will work with those tiles to complete the chart on the worksheet for the first problem. So they'll be pulling tiles and tallying how often they get that particular color. After completing the worksheet, ask the in-conclusion questions and play rows and columns, or the solitaire version of that. These are games A53 and A54 in the Math Card Games book. In lesson 119, we will continue to work with probability. The warm-up is a review of fractions on the practice sheet number 13. The spinners from Appendix 4 and 5, they're not meant to be functional spinners. They're just pictures that we can refer to and think about. The first spinner is divided into 6 equal parts, so each number has an equal chance of having the spinner land on it. However, the second spinner picture is divided into 3 parts. 2 of them are 1/4 of the circle, and 1 of them is half of the circle. Remember that probability is ranked from 0 to 1. If the chance of the spinner landing on a number less than 10 is 100%, because all the numbers are less than 10, then the probability is 1. Likewise, the probability of the spinner landing on a number greater than 10 is 0. Have your student complete the worksheet and answer the in-conclusion questions. Then you can play percentage memory game, which is F46 in the Math Card Games book, and we do have a video or blog about that on our website. So I will leave a link in the description. Lesson 120 does have a correction, so please follow the link in the description if your book was printed before March 26th of 2019. In this lesson, we're going to explore probability using dice. You can have your child complete the multivide on practice sheet 14 at the beginning or the end of the lesson. It doesn't really matter. I always borrow dice from any board game that we happen to have sitting around, but if you don't have any dice, you can always use 4 of each basic number cards 1 through 6, and then just mix them up and have your child turn over 2 cards at a time, add the 2 numbers together, and if the sum is one of the special numbers that we talk about in the lesson book, then make a tally mark for that sum. This is a fun lesson and shows just how unfair some of those games of chance can be. I do want to point out on the worksheet number 3, in the fractions section, so the fraction of the probability, we got the number 36 by multiplying 6 times 6 on the grid above. So that's how many combinations there are. There's 36 choices of numbers. So just so if your child is confused about how we got 36 for that fraction, just refer them back to the grid and say, okay, well, how many numbers are actually there? All right. So then once the worksheet is done, go ahead and ask the in-conclusion questions and play percentage memory again. And that's all for this week. I hope you have a great one. Thanks for joining me, and I'll see you next time. Bye-bye.